80% of candidates fail the Amazon Applied Scientist loop, not because they can't code, but because they are completely blind to the internal bar raiser scoring rubric. From my time as an AI scientist inside these big tech loops, I have watched brilliant researchers crumble because they treated the interview like a thesis defense rather than a business negotiation. The on-site process is a 5 to 6 round gauntlet featuring peers, the hiring manager, and a senior executive known as the bar raiser. This bar raiser is the ultimate gatekeeper who holds absolute veto power. And unlike your hiring manager, who might be desperate to fill a seat, the bar raiser is incentivized to protect the long-term bar. They are literally looking for reasons to say no, to ensure you rank higher than 50% of current employees, which is why a single weak signal in their specific rubric can sink your entire week of effort. One of the most contrarian parts of this loop is the coding assessment, where candidates often waste weeks memorizing abstract graph theory puzzles that have as much utility as a solar-powered flashlight. In reality, the coding bar for an applied scientist is mapped directly to the SDEONI standard, which is Amazon's entry-level software engineer threshold. While a full software development engineer needs to worry about low-level memory management and complex system patterns, your rubric focuses on practical data manipulation. You will likely be asked to write modular code to handle real-world messiness, like implementing a rolling average when your database has missing timestamps. They are testing if you can write production-ready code without needing an SDE to babysit your scripts. So if your solution looks like a tangled bowl of spaghetti code, the rubric will flag you as an operational liability regardless of your modeling skills. Next is the ML depth round, where the interviewers use a mock 1 to 5 scoring matrix to evaluate your mathematical intuition under extreme boundary conditions. If your answer to a problem is just to import a standard library and call a training function, you are effectively handing the interviewer a score of 1. To hit that elusive score of 5, you must be able to justify your optimization landscape with mathematical rigor. For instance, you might be asked how to prevent a model from becoming overconfident. A junior candidate says they will use regularization, but a top-tier scientist explains the mathematical intuition behind label smoothing, showing how replacing hard targets with epsilon-scaled values prevents infinite weight growth. It is the difference between knowing which button to press and understanding the physics of the machine you are operating. While depth tests your math, the ML breadth round is where candidates often fall into the over-engineering trap, trying to build a spaceship when the rubric just wanted a bicycle. This round is heavily graded on the invent and simplify leadership principle. You must systematically demonstrate how you establish a baseline first, using traditional statistical methods to quantify if a multi-billion parameter model is even worth the electricity it consumes. The rubric specifically looks for your understanding of trade-offs, such as how lone versus L2 regularization affects model sparsity, and, more importantly, the operational cost of serving those models to millions of customers. If you jump straight to the most complex architecture without justifying the marginal utility, the panel will mark you down for lacking business pragmatism and technical frugality. A mistake that quietly sinks most offers is treating the technical and behavioral portions as separate events, when in reality, Amazon embeds leadership principle, evaluation directly inside every technical modeling round. While you are explaining a loss function, the interviewer is multitasking, grading your ownership and bias for action based on how you describe your past projects. They will audit your claims by asking why you chose specific parameters to see if you were the primary architect or just a passenger on someone else's project. To master these high-pressure hybrid rounds, I highly recommend checking out Amazon Leadership Principles for a mock answer for every principle, as the link is in the description. You need to weave technical data with behavioral evidence because a perfect model built by someone with zero ownership is a no-hire. When it comes to ML system design, do not prepare for Amazon the same way you would for a Google loop, or you will find yourself optimized for the wrong planet. While other firms might prioritize abstract, distributed pipelines, Amazon's rubric is relentlessly focused on real-world hardware bottlenecks and inference latency. You might be asked to design an ads ranking system that handles 100,000 requests per second, where every millisecond counts. At this scale, The most accurate model in the world is useless if it violates the P99 latency budget. You must demonstrate mastery of hybrid architectures using feature stores for low latency lookups and two-stage ranking models. For a deeper dive into these specific scenarios, check out Amazon System Design Interview Questions, which is an interactive course on exactly this topic, and the link is in the description. One specific technical hurdle in the rubric is the cold start problem, where you have to prove you can handle new users or items without interaction history. The panel evaluates your ability to navigate this using demographic-based initialization or contextual bandits before transitioning to deep recommendation models as interaction data accumulates. If you want to practice these architectural trade-offs interactively, grab Fenzo AI, which spins up a free course on this exact topic in about a minute, and the link is in the description. You must show the rubric that you understand how to use content-based features with text and image embeddings to bridge the gap. It is a test of whether you can maintain a high click-through rate even when the model is flying blind on a brand new item. The ultimate test of a senior scientist is diagnosing the disconnect between positive offline metrics and negative online business results, a situation that has less processing power than a 2005 toaster, if you can't explain it. A classic rubric question asks what you will do when your new model increases the offline click-through rate, but somehow causes actual online revenue to plummet. A naive candidate might blame the users or the economy, but a top-tier scientist looks for sample ratio, mismatches, or data leakage in the training split. You must prove that you can map machine learning loss functions directly to upstream business telemetry. This ability to translate technical jargon into customer impact is why the applied scientist role commands a massive premium over standard engineers, with L6 compensation scales reaching up to $417,000. Now for the 80% failure payoff we discussed earlier, the debugging trap. When a model stops learning, average candidates start throwing spaghetti at the wall by randomly tweaking hyperparameters, which the scoring rubric heavily penalizes for being inefficient. Instead, the rubric demands a highly structured, telemetry-driven methodology. You must establish a baseline, verify your data pre-processing, check for vanishing gradients, and monitor your weight distributions systematically. It is about proving you have a repeatable process, rather than just getting lucky with a random seed. To get your hands on the right mental frameworks, read the book, Top 100 Applied Scientist Interview Questions, as the link is in the description. Having a structured sequence for training failures is what separates the senior scientists from the practitioners who just hope for the best. To survive the Amazon loop, you must replace all behavioral fluff with data-backed telemetry and show the bar raiser exactly how your models drive the bottom line. Whether you are an external candidate or an internal SDE trying to transition by publishing in the Amazon Machine Learning Conference, the standard remains the same. Science must be practical, scalable, and customer-centric. Fortunately, Amazon sticks to a strict operational SLA called the 2 and 5 promise, so you will get an update within 5 business days of your panel interview. If this rubric reveal saved you from a silent fail, drop a like and subscribe so you do not miss the next deep dive into the Faang hiring machine. See you in the next one.